Welcome to English for Professional Mechanical Engineers. It's so nice to see you again. My name is Yiju. In today's lesson, we are going to introduce nanomaterials and the risks. This is a picture of a nanomaterial. These are titanium dioxide nanorods, taken by an electron microscope. The scale bar at the bottom left corner shows the length of 200 nanometers. Therefore, as you may be aware, these rods are narrower than 100 nanometer, but longer than 200 nanometer. Where does tiny titanium dioxide appear in the real world? It's the most widely used white pigment because of its brightness and very high refractive index. Probably you don't believe it. They appear in the food, like the colorful donuts and candies on the left, or the bread on the right. So, titanium dioxide has been applied into food and the bakery industries. In addition, we also see its application in the cosmetic industry, including toothpaste and sunscreen. Approximately 4.6 million tons of pigment titanium dioxide is used annually worldwide, and this number is expected to increase as utilization continues to rise. Okay. We consume titanium dioxide regularly and increasingly, but is it safe? This is a figure demonstrating the toxicity of titanium dioxide. The horizontal axis shows four materials: PBS, titanium dioxide dots, titanium dioxide rods, and titanium dioxide base. A low concentration of 1 mg per kilogram and high concentration of 5 mg per kilogram. PBS is a buffer solution commonly used in biological research. We can just treat it like pure liquid solution without nanomaterials. In addition, the data were collected after 24 hours, 1 week, 1 month, and 3 months. But here we can only look at the data of 24 hours at this moment. As a result, you may be aware that, first, the 3 nanomaterials of titanium dioxide are more toxic than PBS, the buffer solution. Secondly, nanomaterials at a higher concentration of 5 mg per kilogram is also more toxic than those at a lower concentration of 1 mg per kilogram. Therefore, the more titanium dioxide, the more toxic it is. Here is another research result of titanium dioxide. It studied both rats and mice with the same conclusion that the inflammatory responses of titanium dioxide may be size-dependent. Inflammatory is a medical term. It means causing or related to swelling and pain in the body. As you may see in the charts, the line of 20 nanometer particles is more acute than that of 250 nanometer particles. It demonstrates that smaller size elicits higher inflammatory responses. Therefore, smaller size is more risky for the body. Titanium products are not the number one nanomaterials available in the market. Based on this chart, silver has been fabricated for nanomaterials most popularly. It covers 55% of the nanomaterials. Titanium product is number 3, covering 10% of the whole nanomaterials in the market. Are nanomaterials are more toxic than larger particles? According to some research results, The answer is yes. They are more toxic than fine-sized particles of identical composition. However, the conclusion is only based on the materials of titanium dioxide, carbon black, and diesel particles. Therefore, it's argued that the current hypotheses are based on a paucity of data. It means the components of nanomaterials which have been studied are limited, and therefore its conclusion is not persuasive. Outline. What will this topic cover? So far, we have briefly introduced that size matters. When materials are at the nanoscale, they demonstrate different properties to large particles. Next, we will mention what are nanomaterials, the definition. Then, what are the promising applications of nanomaterials? Finally, what are the risks to these tiny things? Alright, what are nanomaterials? Nano means 10 to the power of -9. So, when we talk about nanomaterials, at least one dimension of the material should be less than 300 nanometer at the nanoscale. Theoretically, there are two types of nanomaterials. One is non-manufactured. It is created unintentionally. Human beings don't produce them on purpose. Usually, they are just some byproducts like PM 2.5. It's right now very famous because it's ultrafine dust from factories and causes the problem of air pollution. Second one is manufactured nanomaterials like carbon black in tires and toner. In addition, it's also used in making medicines and iPads. Okay, these are two kinds of nanomaterials. One is a byproduct from combustion of engine, and it becomes air pollution. The other kind is manufactured nanomaterials. Let's take a moment to look at the second kind. Manufactured nanomaterials. First, let's recap the definition of nanoscale. Nanoscale typically means the size of the subjects is between 1 and 300 nanometer in at least one dimension. 1. It could be nanofibers, nanotubes, and nanorods when one of the dimensions is less than 300 nanometer. 2. Nanomaterials could be nanoparticles when 2 or 3 of the dimensions are less than 300 nanometer. So, nanofibers, nanotubes, and nanorods are one dimension at the nanoscale, while nanoparticles are 2 to 3 dimensions at the nanoscale. Was that clear? Alright, let's move on. This is a scale that we always see when talking about nanotechnology. It can help us realize how small the nano is. The button is 0.1 nanometer. It's about the size of one small atom. While we use the nanometer scale to measure DNA or carbon nanotubes, we measure a red blood cell or the wisps of human hair with micrometer scale. Interesting, huh? So, what's the big deal to make materials in nanoscale? One big thing is that is why Gecko can climb a glass surface, but you cannot. But why Gecko can climb a glass surface? What is the special power that a gecko has? Okay, it is called van der Waals force. Their feet have nanomaterials, as you may see in the photos. The nanostructures create tiny van der Waals force in each tiny nanostructure, and the tiny force is accumulated and supports a gecko to climb a glass surface. Another thing which is make nanomaterials famous is lotus effect, like the photos on the top. Again, it is because the surface of the lotus leaf has many nanostructures. This effect is so useful and has products available on the market. In addition, the number of publications on nanotechnology and nanoparticles is increasing at an incredible rate. So far, we have covered introduction and explained what nanomaterials are, including the definition, categories, and effects. Next, we will introduce some promising applications and its risks.